Okay guys, so here's another little quick video. I got this wire, one of my previous videos I talked about it. It's the low speed power wire on the air conditioner. And I want to show you how you check a diode. Diodes are like check valves. They only allow the current to flow one way. So, you know what? This is going to be kind of hard with one hand. So what you do is you set up... Oh, I got this... I'm so excited about this volt ohm meter. And I'll tell you, this little diversion here. What's so great about it is it's got AC and DC amperage up to 1,000 amps, which in my whole life I've always wanted to get an inductive pickup for DC amps, but couldn't afford them because they were so darn expensive. And I've shopped on and off, you know, over 30 years of looking for these things, and this just happened to show up. I don't know how I ended up looking at this thing on Amazon. You know, they got this stuff figured out. And so I picked this thing up as an impulse buy. It's got voltage, AC or DC, and frequency, and percent, which I believe is duty cycle. We got this neat hold feature. Unfortunately, it does, at least I don't think it has the capability of doing hold on like the highest. It just holds on whatever you're reading. Hold on highest would be kind of cool, or I don't know. I just thought that would be kind of neat. Then we got your resistance in ohms. It also has a diode check. Diode check uses higher current flow, and it has a beeper. We got temperature in C and F, and then you got your 40, 400, or 1000 range of amperage AC or DC. And man, I'm just loving this thing. It's everything. And it also, where's the capacitance also. It's capacitor tester, capacitance tester as well. And you do that by going through your mode and all that neat stuff, and it displays. But anyway, right now I've got the thing set up with beep. And what I like about it, I got a very expensive Fluke 87 automotive meter, and when you have it set to beep, there's this tiny delay before it actually beeps. This is like instantaneous. And you can even hear with the little bit of crackling that, you know, the poor connections I'm making every once in a while, you could tell. So anyway, this is give me an audible, and it also reads the ohms, which I'm not worried about for this circuit test I'm going to do right now. This diode in the middle is fried. I've already checked it just using a test light. Quite a bit of current goes through here. I'm going to guess a few amps of current goes through that thing normally, so a test light is not enough current to hurt it. That's why I use a test light to test it. I like using test lights better than ohm meters to check, for the simple reason it's very easy to see what's going on, and it's quick and easy, and it puts a little bit of a load on the circuit. So if we put our ohm meter right on that end of the wire, when we touch the other end of the wire, it should beep. Nothing. Nothing at all. And that means it's not even reading any kind of resistance. Okay? So this doesn't tell us that that diode is bad, because that diode is only going to allow current to flow in one direction. So the next thing you got to do is swap your leads. You can swap it anyhow you want. I'm going to just do that because I'm working with one hand and one leg here to do this. So we stick this in there, right? Double check our meter still doing what it's supposed to do. Now if I touch this end, I should get a beep if the diode is good. And it does not beep. So that is fried, like I already checked. And I'll show you the other way, the way I actually tested it originally I brought the meter out here because I want to see how much amperage the low circuit draws on my air conditioner when I jump it, to know how much of a diode I need to replace. I'm not sure that that is in there for no reason. So what I had done, I used my test light. I had the key on and I had power at this terminal right there, and the light would illuminate with the other end of my test light hooked to a good ground. So you always check to make sure the thing works. It's not coming on now because I don't have the key on. So then what I did is I did the same test I did a minute ago with my test light plugged in to one end of the wire, then the other end of the wire I touched to the power supply, and the light on the test light did not illuminate. Then I swapped the wire around the other direction and the light still did not illuminate. And that proves for absolute certainty that that diode is burn up, baby. So here we go. I guess I'm going to just keep on talking. So the next thing I wanted to do, I got this test jump lead here, and I'm going to hook this jump lead up to this wire. That's the power supply, and I'm jumping where that other red wire used to go. And I already did this, and the low fan works when I jump it. So before I turn the key on, because the low air buzzer is going to be, and it's going to be loud, I'm going to put this thing on an amp scale right there, and I got ranges, but it's going to be just fine there. And I'm going to show you how this works. So we're going to turn the key on. We're on low speed, medium, high. All the speeds work like they're supposed to. And low is working because I have the bypass in. And so I want to see how many amps we got drawn on that circuit. So we're zeroed out pretty much. Alright. And all you do is you take your meter and you go over one conductor in the circuit, like so. And now we can see it's about a little less than 7.5 amps. It's reading negative. It just happens to be that I've got the meter backwards. It means nothing. It's going to read. I'm only looking for amps. I know it's not negative amps. If I take the meter and turn it around and clamp it on the wire, it'll now be positive, not a negative. So if I decide to put a diode back in the circuit, I need to make sure that it's like a 10 amp rating or something, and we'll be good to go. I'm going to do some testing later on. I've got a few diodes probably that I could put in parallel. I know I don't have a 10 amp diode. I think I've got some 3 amp diodes that I can take like three amp diodes, put them parallel side by side, and hook them in the circuit and see if that little bit of voltage drop that a diode's going to give us, that 0.7 volts voltage drop, which I believe is 0.7 volts, if that brings the fan speed down just a little bit and makes it a little bit more pleasant. Okay, so I went digging in my box full of goodies, and lo and behold, I happen to find some diodes. They're rated at 6 amps, and they came from Radio Shack possibly as much as 10 years ago. So here's what we're going to do. I never memorized which way you put a diode in a circuit, the positive and negative. One way current flows and the other way it doesn't flow. But I'm going to test this, and I'm going to share it with you. And I'll show you how I'm going to do it. I'm going to use the same circuit for a power supply just because it's there and it's easy. Turning on my key. Okay, so you can see the fan going, and that's about 7 1/3 amps worth of power, which is too much for one of those diodes. It might take it, but it probably won't. So what I'm going to do, instead of running the fan to double check which way I have to install this diode with the little painted stripe facing that way or the other way, I am going to disconnect the fan, and I'm going to use my test light. So I got a ground on the test light, and I got power coming where it normally would come. Let me untake this knot out of here. Alright, so if I take my test light, I can't do this, man. One-handed. I probably ought to get a GoPro or something. So if I put the test light on the wire, current flows and light glows. So now I'm going to take the diode, and this will be a good exercise of showing you how to test the diode anyway. Right? Nothing. Turn the diode over. Power. So that's the direction we need to put the diodes in. The painted stripe needs to go toward the resistor in the circuit. So now that we got that figured out, I'm going to show you how I'm going to build the wire assembly. And turn off that darn key. There's the original wire. That's the end of it that goes to the resistor. And I'm going to solder up the wires. Oh, there's the original diode, by the way. The mistake I made is I cut the darn thing before noting which way it went. New, old. So I cut the wires on these new diodes because I'm going to put them together like that. I'm going to solder with the painted stripe end. This end is going to get soldered to this wire. Alright, and the other side is going to get soldered to the power supply wire. Alright guys, so one more test before I make the final crimp. I decided to go with crimps, and I might actually solder after I crimp it just to make sure the connection's good. But we got the power supply right here, and if you listen to the fan speed, okay, 0.7 of a volt lower. You know what, I'll do a voltage check too, just to double check on that. Listen to the difference. Just the slightest bit different, slower. So I'm compelled to put these diodes back in there because maybe running at low speed, this causes some interference and it dorks around with the computer system or something. So there you got it. So if I were to swap this thing around and put it backwards, the fan won't run. Alright, I'm going to try to make this as clear as I can. I got my meter hanging on this clamp up there, and that's not doing anything other than supporting the meter. Because I don't have it on an amp scale, I have it on volts. So we're reading about 3/4 of a volt. And what that is doing is it's measuring the voltage drop across the diodes. So some of the power, most of the power is going through, from the power supply through the diodes up to the fan motor. A tiny bit of the power is going through the meter. and it's registering what the voltage is. That's the meter's reading it. So I changed the game plan here. I moved the resistors to the end of the wire so they'll be accessible without having to go through all that mess again, opening up that split loom. I already taped the ends. I like taping the ends on the loom. And I reconnected everything. It's all wired up. It's done, man. Except for putting the cover back on. I put my little tie wrap right here to get this thing some stability. These things get warm, almost so much that you can't leave your fingers on. Like, that's about it. So I thought it'd be also a great idea to put it in the Airstream here to keep them cool. And there you have it. All right, I hope that makes some sense. Later, guys.